The previous video we had learned about Newton's law of octaves and Lothamir's periodic table. In this video, we are going to be talking about Mendeleev's periodic table. Dmitri Ivanovich Mendeleev was the Russian chemist and was the first to publish a periodic table with the periodic law. So actually, he was a teacher and he started writing two books on chemistry. And while he was doing the same, that's when he noticed that there was something unique about the periodic table and like how he should be classifying it. So he says that it was in a dream that he had got to know about how to classify the elements that the way he did. He actually didn't know about the existence of the various classifications that had already been present. And it was actually, he actually published his paper a few months before Lothamier's paper, and Lothamier's paper was actually published in Germany, while Mendeleev's was published in Russia. So, according to the Mendeleev's periodic law, the properties of the elements are the periodic function of their atomic weights. And he published his final periodic table in the year 1905. Initially, he published the first version in the year 1869. And he called the horizontal rows as periods and the vertical columns as groups. Now, he had arranged the atoms in the order of their increasing atomic weights. Now, he noticed that the elements they fell under a certain groups or families, and so they showed a similarity in properties. Not only that, he considered that each of these elements formed, or rather he considered the empirical formula, I'd rather say this, empirical formula of various compounds formed by the elements. So the all the elements of a particular group tended to form a compound similarity in their empirical formulae. Now, there were cases where elements did not follow their increasing order of their atomic weights. If you can see, if I can say, tellurium and iodine did not follow this order. Um, but iodine has a lesser atomic mass than tellurium, but despite that, he placed it after tellurium because he wanted them to come under, he wanted iodine to be under chlorine and bromine because of the similarity in properties. Now, it was actually Mendeleev's periodic table which basically changed the way the atomic weights of certain elements were basically assumed to be. And for example, I think uranium, right? Uranium, according to that time, its atomic mass was found to be was thought to be 120, and its valency was supposed to be 3. But it was Mendeleev who changed its atomic weight to about 240, and currently we know its atomic weight is 238, and the valency to be 6. So he changed the atomic weights because at that point in time, there was not a lot of the sensitivity of the instruments was not that high. So that's why there was a change. And also, he also left empty spaces in which as new elements were found, they could be added. For example, Ica aluminium, Ica silicon. Ica aluminium was later found to be gallium, whereas Ica silicon was found to be germanium. At that point in time, they had not known about its existence. And if I am not wrong, he also left a space for scandium, which was later found to be, scandium, yeah, obviously. Uh, so there were various contributions by Mendeleev's periodic table. They were study of the elements. So study of the elements was much easier with Mendeleev's periodic table because of the repetition of properties and similarity in properties that he observed. So it was relatively easy for scientists to study the properties of various elements. Now, this also meant that it was easy to remember these properties as well. Second was correction of atomic masses. As I told you, iodine has a lesser atomic mass than tellurium, but it was placed after tellurium because of the similarity in properties. Similarly, uranium was also placed over here, and technically its atomic mass at that point in time was assumed to be 120, which means it would have been placed somewhere here, but he basically doubled the mass that they had known then. And currently, as I told you, the mass is 238, it was found to be. So there was various elements which he corrected the atomic masses of. Other elements include beryllium, indium, gold, and platinum. Not only that, he predicted new elements. There were only 56 elements which were known at that time, and it said that at that point in time, average of at least one new element was discovered each year. So the main issue with Lothar Meyer's periodic table was that he did not leave any gaps for other elements or for new elements to be placed in. But Mendeleev left gaps for elements to be placed in. Not only that, he predicted the presence of or the existence of certain elements with similarity in properties to that of the others. So, for example, you have Ica silicon and Ica aluminium, that is gallium and germanium. Sorry, germanium and gallium. So, Ica silicon was found to be germanium, this one, and Ica aluminium was found to be gallium. So that was a very interesting or new take in the elements classification. I'm so sorry. Now, defects. The issue was or problems with Mendeleev's periodic table. The first one, position of hydrogen. So, as we know now, hydrogen has valency of 1. Okay, and I think you would have learned in grade 9 that it can either take an electron or give away an electron. So if it loses an electron, it just has a proton. And if it gains an electron, it shows the configuration similar to that of helium. Right. So according to Mendeleev's periodic table, it was placed under group 1, but it showed similarity in properties of group 7 as well, which is fluorine, chlorine. All of these elements tend to gain an electron, gain the stability or the complete electronic configuration is that of noble gases. So the position of hydrogen was not very clear in Mendeleev's periodic table. The second one was anomalous pairs. So certain places, if you notice, the increasing order of the atomic masses rule was not followed. He arranged the elements based on the increasing order, based on their properties, similarity in properties. So argon, which had the mass of 39.9, was placed before potassium, which has a mass of 39.1. If you see, next one, cobalt, which has a mass of 58.9, was placed before nickel, which has a mass of 58.6. And tellurium was placed before iodine, as we know. 127.6 is the mass of tellurium, and 126.9 was the mass of iodine. So he himself did not follow the law of or the periodic law when there was properties that was involved. Next, position of isotopes. So isotopes are basically substances or rather atoms which have the same atomic number but vary in terms of atomic mass. Now, if Mendeleev's periodic table considered atomic masses, then obviously there should have been a place for isotopes as well. For example, hydrogen has 2 isotopes, deuterium and tritium. Hydrogen as such, protium is the majorly found isotope. But deuterium and tritium should also have had a place in the periodic table, but that was not the case. Next one, Mendeleev was not able to explain, few similar elements are separated while dissimilar elements are grouped together. So according to Mendeleev's periodic table, copper and mercury, they have similarity in properties, but according to basically because of the periodic table, they were placed far apart from each other. Next, lithium, sodium, potassium were placed along with copper, silver, and gold. And these elements do not have any similarity in property with that of lithium and sodium and potassium. And so they were basically dissimilar elements which had been grouped together. Next, Mendeleev was not able to explain the reason for periodicity. He said that according to the periodic law, properties of elements are the periodic function of their atomic weights. But Mendeleev could not explain why this was happening. He just said that this happened, but there was no clear reason as to why there is a repetition of properties. Next, position of lanthanoids and actinoids. If you've seen the modern periodic table right now, we know that lanthanoids and actinoids have a separate place below the periodic table. But according to Mendeleev's periodic table, there was no separate space for lanthanoids and actinoids that placed along with them. So in this video, we learned about the Mendeleev's periodic law, the properties of Mendeleev's periodic table, and the contributions as well as the defects of the periodic table. With this, we complete the genesis of the periodic table. So in the next video, we will be discussing about the modern periodic table.